All right, so sorry. And then as we have promised that it's going to be at exactly 8:30. If you can hear me clearly, please just comment yes. If you can hear me clearly, can you comment yes? If you can hear me clearly, can you comment yes? If you can hear me clearly, can you comment yes in the comment section? Clearly, if you can hear me clearly, can you comment yes in the comment section? Okay, thank you. Thank you, everyone. I don't know if our representative is here. All right, thank you. Thank you. If you can hear me clearly, let's just comment yes. Let's just comment yes if you can hear me clearly. If you can hear me clearly, can you comment yes, please? Okay, thank you. So what I'm trying to do is I want to make sure that we have as many as possible that could join us. Immediately after this class, what we'll do is in the next uh, 10 minutes is just to do a kind of an opening of what the class is all about. Then we use the remaining time to do our calculation. Like I've said, this is just going to be a purely calculation class. So without wasting much of our time, you're welcome into the class. And like I've said, uh, we break down one of the most important concepts in education statistics, which we call measure of dispersion. And of course, as those of us that were part of the class at the beginning, we said statistics is basically divided into two. We have what is called descriptive statistic and we have what is called inferential statistic. We have given a definition to this. And if you want more definition on that, you can check the previous video or you can check one of the videos that talk about the meanings of statistics here. So as an educator, you need to understand the student performance goes beyond average. Most of us, what we do most time is that, okay, you want to find the average of the scores of the student. You just gather all the scores together and divide by the total numbers of the student. So, but we want to see how to perform the scores of a student or the student data beyond just calculating the average. So we must also look at how scores are spread out, how consistent learners are, and what this pattern tell us about their learning needs. So this is going to be a kind of giving you more and high opener about the spread of the scores of the student. What does it mean? So in this class, I will just be telling you what measure of dispersion mean, why they are essential for you as a teacher or as an education or as an educationist or as an educator. So how to interpret the range, the variance, and then the standard deviation. I also talk about the simple example using both Ungrouped data and then group data. Then how this measure support classroom decision, how you can use this to support your classroom decision as a teacher. So if I may ask, majority of us may be wondering, what is the meaning of measure of dispersion? The measure of dispersion are statistical tools used to describe how far the data values are from the center, such as the mean, the median, and the mode, from one another. It's just all about how data's value are what? The data value are from the center, how those data were spread, the spreading out of the data. So as an educator, we often work with some of these data like scores, like I've said, the attendance of the student, the performance trend of the student, the classroom assessment. So why average, that we are talking about the mean median mode, that one is just telling us what is typical. They do not tell us how spread out or consistent the data is. So what the work that the measure of dispersion is going to do is going to tell us how the data were spread, how the data were what? They were spread. So they are going to help us to understand the variability, the consistent, or the stability of a set of numbers. So that is what the measure of dispersion is all about. So in simple terms, the measure of dispersion is low. The student performance at similar level. If the data is low, so the student perform at a similar level. If the dispersion is high, the student performance differs widely. So if the dispersion is low, the student performance at a similar level. That means they have something in common. But if the dispersion is very high, the student performance differ widely. So why you as an educator, why do you need calculation related to measure of dispersion? Number one is for you to understand the spread of student performance. So let's say two classes may have the same average score, but one class might have more consistent performance. You see, sometimes when you see some of those data, you just find out that some students just get 40, 40, 40, 40, 40, 40. While some get 70, 70, 70, 70. Some get 20, 20, 20. Some get 50, 50, 50, 50. You can see that the spread of the data. So knowing the variation will help you to identify whether the class needs general revision or they need target intervention. So that is the first important of measure of dispersion to you as an educator, is to understand the spread of the student performance. Number two is to identify the learning gap. A wide spread in your student score indicates that some of the students are far behind or far ahead. So it's going to guide you to apply different teaching strategies. Just like what I've just said, you just observe that some of the students get 50, 50, 50, and you have some set of students that got 70, 80, 70, 80, 70, 80. So the data is being spread out. So you have to identify the learner's gap. Why are those getting 50 meeting up with those people getting 70? Why is the spread? That's the second important. The third important is that it allows you to evaluate the fairness and effectiveness of your test. An assessment with extremely high or low variability may not be well balanced. So dispersion is what is going to help you to check if your test is too easy or too hard or unfair. So it's not all about you just conduct test for students and you just want to align the data. It's beyond that. It's beyond knowing the average of this average score. So the number four is that it improves decision making in education. A data-driven decision, such as a grouping student, adjust the teaching method, or designing the remedial class, depends on the understanding variability. I'll just give you an instance. You conduct a test. Some of them get low mark. Some get high mark. The scores are not well spread. It shows that those that got the low mark, they are not going with the class. While some of the students that get high class, probably they have a prior knowledge somewhere, or they have something that makes them to go ahead of the other student. So the number four important is that it's going to improve your decision making as an educator. A data-driven decision, such as, like I've said, is going to improve your decision making as an educator. So it's also going to support educational research, especially for those of us that go into research. We're conducting classroom research or writing report on measure of dispersion. Is going to help you to improve more complete and meaningful statistical analysis beyond average. So there are some common measure of dispersion, as we know. I don't know if you know any one of them, but I'm going to tell you here that one of the measure of dispersion is what? Is range. Finding the low mark and the average mark is a common measure of dispersion. And at that particular moment, range is to find the difference between the highest value and the lowest value. The second one under the measure of dispersion is variance. Is an average of the square difference from the mean. An average of the square difference from the mean. That is variance. The third one is standard deviation. The standard deviation is just a square root of the variance. It shows the typical distance from the mean. That's why they call it the standard deviation. The third one is the quartile range. You know, in our last class, we talked about quartile, where we have the first quartile, the second quartile, and the third quartile. So the interquartile range is the spread of the middle 50% of the data. So when we come, we talk about the interquartile range. How do we get an interquartile range? That's just to find the difference between the first quartile and the what? And the last quartile. That is the interquartile range. So I'll be telling us some of the examples we'll be using in the class, and then we'll quickly look at the example. So what I'm going to do now is to please, if you can hear me clearly, can you comment yes? If you can hear me clearly, you can comment yes. And I want us to run into the comment section. Just run into the comment section. Tell me the 3 things that measure of dispersion is all about. The big phone. So let me have it in the comments. What are the common measure of dispersion? So let's go into the comment section and tell me what are the measure of dispersion now. Let's meet in the comment section. What are measure of dispersion? Can you tell me what are measure of dispersion? Can we have that in the comment section? Thank you, range. What other things? Somebody has talked about range. What other things? I'm waiting for you in the comment section. Range, variance. What other things? Range, variance. What other things? Okay, standard deviation. Okay, so now let's now use this data. We want to use this data now. This data that I've just put now. So we want to find let's look for the range, the variance, and standard deviation. So the first thing is that, can you find the range of that data that is in the comment section now? Can we find the range of that data in the comment section? So let's meet on the other side. Yes, what I have here, quartile range. Thank you. So I've given you a set of data. Can you find the mean of that data? Let's look for the range. What is the range of that data? Range. What is the range? What is the mean of that data? Okay, thank you. Excuse me. Please, can you hear me? If you can hear me, let me know. Let me know in the comment section if you can hear me. If you can hear me clearly, let me know in the comment section. Please, if you can hear me, let me know in the comment section. If you can hear me, let me know. Just type yes in the comment section. Okay, thank you. I can see somebody telling me. So, can you find the value now? Can you find the value now? Can you find the value? So, put in the comment. Yes, thank you. Thank you. Okay, thank you. I can see that. So, I want someone to just. So, let's do correction to that. If you didn't get it. I can see that. So, I want someone. So, let's do correction to that. If you didn't get it. So, I want someone. So, let's do correction. Okay, so let's have the data now. So let's have the data. I think I have the data here. So I want to see how the data is spread. So we have 6. We have 6, 8, 10, 12, and 14. So for this now, this is just an ungrouped data. So the first thing we have to find here is that if you want to talk about the range of this value, so we look at the highest value. Let's look at the highest value. So the highest value here, highest minus lowest. So the highest here is what? Great, that is 14, minus the lowest, which is what? 6. So the range of this data is just what? Just 8. So the next thing now is that if you want to find the variance now, we want to look for the variance and the standard deviation. So the first thing is, what is the formula for finding variance? What's the formula for finding variance? Great. So the formula for finding variance here is just summation x minus what? X bar, which is the mean, all square, everything divided by what? The n. That is the total number. Why the standard deviation is just square root of what? Variance. is just for you to square the variance. That's for the ungrouped data. So when we come to the group data, we'll also talk about that. So let's use here now to find this now. So how do you now find the variance for this? When we look at it, it's talking about the x, which is the observed value, minus the mean score. That means we have to take this mean score away from this. So that means the first thing you just have to get is to first of all get the mean value. So that means there is need for you to get the what? The mean, which is x bar. So what is the mean? So what is the mean? So the mean is just the summation x, everything divided by what? N. That's just the mean. So the summation x simply means you are going to add all this together. So let's add it together. That's 8 plus what? 6 plus 8 plus 10 plus 12 plus what? Plus 14. Everything divided by 1, 2, 3, 4, 5, which is what? 5. So let's add. So when you add everything together, what do you get? I can see some people have got mean here. So what is your mean? I can see a lot of people. Some said the mean is equals to 10. Okay, I can see that. So if the mean is equal to 10, can we add all this together? So when you add everything together, 6 plus this is 14. 14 plus 14, that's 28. Plus, what do we have here? Plus 22. That is going to give us what? 50. So 50 divided by 5, and that will give us what? 10. So truly, the mean is equals to what? Is equals to 10. So you can see the reason why the mean is. Now, to come back to variance now, that means we need to get our x minus x bar. So to get that, that means you are going to take this mean value away from here. So that will be 6 minus 10 all square. Let me square this before I come back. Everything divided by what? This. Don't forget that this is summation. So 6 square plus 8 minus 10 square plus 10 minus what? 10 square plus 12 minus 10 square plus 14 minus what? Minus 10 all square. Everything divided by what? 5. I'm sure it is clear in that way. I just want to try to manage that side. So when you come here now, take 10 away from E. That is 4 square plus take 10 away from there. Don't forget that this is an absolute value. Let me put this one as an absolute value. So even if you get negative, an absolute value will make it to become a positive. So take 10 away from here. So that become minus what? Minus 2 square plus 0 square plus take this 2 square plus take 10 away. That's minus 6 all square. Everything divided by what? 5. So 4 square. That's 16 plus 4 plus 0 plus 4 plus what? Plus 36. Add everything together there. What do you get? I want to see what you get there. So what do we get in that place? Is that going to give us final results? So let's add them together. 6 plus this, that is 20. 20 plus, that's 40. That is going to give us 60. That is going to give us 60. So let me clean this side for you. Blah, 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 blah. So 6 plus 4, 16 plus 4, that's 20. 20 plus 40, that is 60. So that means it's equals to 60 divided by what? Divided by 5. How many 60 can we see in that? Great. That will give us 12. So 12. So that means our variance is equals to 12. So our variance, which is equals to summation x minus what? X bar all square divided by n, which is equals to 60 divided by 5. How many D's can we see in that? That's 12. So that means our variance is equals to what? Is equals to 12. So to get our standard deviation now, that is just going to be square root of what? of variance. Can you confirm that answer if it is correct? If it is correct, can you confirm? What's your variance? What is your variance? What's the variance? Those that are working with me, what is the variance? Can you put it in the comment section? What's the variance? Is that correct? I want to be sure. So what's the variance? So what's the variance? Can you put it in the comment section? Okay, I can see the last value there. Yes. The last value there is what I want to check. Yes, I want to quickly cross-check that. This is 14. Yes, this is 14. This is 14. So take 10 away from 14. That's going to give me 4. I'm looking at it. So when you square 4, that is going to become 16. That is going to become 16. So that means this place is equal to 16. Can you capture that? So that this place is equal to 16, not 36. So when you add that one together with that, what is that going to become? Okay, can you add that now? So this is 20. This is also 20. So that means this place is equal to what? Is 40. So it's 40. So how many 5 can we see in 40? That is what? That is 8. Yes, that's exactly what I'm looking for. So can you see that now? If you can get that, can you put it in comment section? I can see someone working with me. Okay. So let's correct this place very well. Let's correct this place very well. Let's correct this place. Can you see where the error lies? This one is 14 here. This is 14. So that means you are taking 10 away from 14. Great. And that is 4. So that's where we get 4 square is what? That is 16. So let's come back here now. So that means we have this as what? As 40. So how do we get this? This is just, let me clear here so that you can see it clearly from here. Let me just clear it clearly from here. So how do we get this? This is just 6 minus 10 all square plus 8 minus 10 all square plus 10 minus 10 all square. The 10 is the mean, plus 12 minus 10 all square plus 14 minus 10 all what? All square. So when you square this, take this away. This is 4 square plus 2 square plus 0 square plus, take this away, 12. That is 2 square plus, take this away. This is 4 square. So, and this is becoming 16 plus 4 plus 0 plus 4 plus 16. And then when you add everything together, 4 plus 16 plus 4, that's 20. Plus 20 again, that is what? 40 divided by 5. So when you divide 40 divided by 5, it's going to give you what? 8. So when you find, so that means our variance is equal to what? 8. So the standard deviation now will just become square root of what? 8. If you have calculator, you can press it. You can also use the short form. This is just 4 multiplied by what? This is just 4 multiplied by 2. And the answer of square root of 4 is what? 2 root what? Root 2. So that is your variance. Is that clear? So if you get it, can you put yes in the comment section? If you get it, can you put yes in the comment section? If you get it, can you put yes in the comment section? If you get it, can you put yes in the comment section? Okay, thank you, Taiwo. So you are quickly going to take this before I will put another question on the board for us. So can you find this for me? Let me say 4 plus 7. 4 plus 7. 4 plus 7 plus 9. Don't worry. Okay. Let me say plus 6. Let's make this 7 plus 3. So can you find this? So use this one, find the range, find the variance, and find the standard deviation. Number 1, range. Number 2, variance. And number 3 was standard deviation. So put your answer in the comment section for me. Excuse me, can you put your answer in the comment section? So before I go on to the other side, then we'll go ahead and look for the group data before we call it a day. So let's do that quickly. I'm looking for your answer in the comment section. So waiting for your answer in the comment section. So I'm waiting for your answer. I'm waiting for your answer. So I'm waiting for your answer in the comment section. So I'm going to quickly give you this as a. So I'm waiting for your answer in the comment section. So waiting for your answer in the comment section. So let me give you this. So you have picked, since you have picked your question, so let me give you this as a group data now. Let's say we have the class size or class interval, as it may be, 1 to 5. So if it is 1 to 5, that is 6 to 10, 11 to 15, 16 to 20. I think I have just that. 16 to 20, 21 to 25, and 26 to 30. So I'm moving now to group data. I just want to drop this before I will confirm your answer there. So the frequency now. The frequency, let me give you the frequency as 4, 6, 8, 10, 12, and 10. That's 4, 6, 8, 10, 12, and 10. So that is a group data. Now the first thing to know on this, okay, let me check the comment section for your response. So we are going to suspend the class here. Probably maybe when next we meet, we'll complete the data. So you get the data on your own. Okay, I can see different people finding the mean. Okay. Some are saying the range is this. So let's move to the group data now. The first thing you need to do before you go to the group data is to, first of all, let me clean this table. Let me clean here and write the formula, because the formula matters most. It is the formula that will determine how you are going to do your work. It is the formula that will determine how you are going to do your work. So the formula here now for the variance is R squared is equals summation F into X minus X bar all square, everything divided by summation F. I will repeat the formula again. Summation F, you can use an absolute value symbol or you use bracket, X minus X bar all square, everything divided by summation F. So why the standard deviation R is equals to square root of what? Of variance. Now, when you look at this formula, there are a lot of things there. The first thing is that you need to get your F. There is a point where you need to get your X, the mean deviation, that is your X minus X bar. Then there is a point where you are going to get your X squared. So for you to get this now, so I have to label the table. So you have get your frequency. This is your frequency. It's given. The frequency is given here. So what you just have to do here is that you want to look for the X, because there is a X here. It is quite different from that of what? On group data. So that means you need to get your X. So your X here is the midpoint. Can you see that? So you need to get your X, which is the what? The midpoint. So what is the midpoint? The midpoint is just that you had this class interval together. 1 plus what? Plus 5. So that is 1 plus 5 to be divided by 2. So 1 plus 5, that is 6 divided by 2 is equal to what? 3. So the second one is just 6 plus 10 divided. 6 plus 10 is equal to what? 16. 16 divided by 2 will give us what? 8. Like I told us in our previous class, that once you get the first, second, third, or you first, second, you don't have to stress yourself again. It's just adding the class size. So when we look at it here, what is the class size? Count your hand like primary school student. 1, 2, 3, 4, 5. That means the class size is just 5. So, and that is why after 3, you get 8. So the next one is that 5 plus this. 5 plus 8. Great. That is 13. 13 plus this. 5 plus 13. That's 18. 18 plus 5 plus 18. That's 23. 23 plus 5. That is 20 what? 28. So that is the what? The midpoint. So I'm going to leave you with this so that in our next class, we complete this. So since you have got your frequency now and you have got the value of S, which is the what? The midpoint. So the next thing now is for you to find your what? Your X bar. The X bar is the mean. So that means there is need for you to find the mean, which is the X bar, which is very, very important. And don't forget that the mean is just summation F X divided by summation what? F. So that means you have to multiply these two together. So find Fx by multiplying these two together. So how do we get that? Fx, 4 multiplied by what? 3. 4 times 3, that is 12. 6 multiplied, that is 6 multiplied by 8. 8 multiplied by 13. Then you come here, 10 multiplied by 18. Then 12 multiplied by what? 23. Then 10 multiplied by 20 what? 28 to get your Fx. So can you get that for me? I want all of us to, I want to charge us to work now. Can you get that for me? Can you get that for me? Okay, please confirm if you can see the board now. Confirm if you can see the board now. Confirm if you can see the board now. Please confirm for me if you can see the board. Okay, so without wasting much of our time, I'm going to clean this. Since I've shown you how to get it, I'll just clean this. So 6 multiplied by 8, that's 48. Okay, let me fix this so that you can hear me clearly. Or let me just hold it like that if you can hear me clearly. So we have this as what? So 6 multiplied by 8, that is 48. 8 multiplied by 13, that is going to give me 104. This is going to give me 180. This will give me 276. And this will give me 280. So for addition of these, the total is going to give me 900 if you do it very well. So that means this is going to become 900 divided by the total here. What is the total here? 50. So divided by 50. So when you divide this will cancel this. How many 5 can we see in this? So can you find that too? So the mean value here is equal to what? 18. So that means your X bar is equal to 18. There are some cases they may give you what to call assuming mean value. So, but for this case, it's not like that. We have to find the mean. So we have got the mean value here now. We have got the mean value here. So our mean value is just 18. That's our mean. So here now, at this point now, you have to come and find X minus what? X bar. And X minus X bar is X minus what? 18. So that means you are taking 18 away from all the values of S. That is 3 minus 18. 8 minus 18. Then you do it like that. So can we get the value of that one? Can we get the values of that? Can we get the values of that? So this is going to become 13 minus 18, 18 minus 18, 23 minus 18, 28 minus 18. So I need the value. So this will give us minus 15 and this. So let's continue. That will give us minus 10. This will give us 13 minus that. That's minus 5. This is equal to 0. And this is going to give me 5. And this will give me what? 10. Is that clear now? So what else do we need here? So we need to square this value. So that is x minus x bar all square. So that's the second to the last stage. So at this point now, you just want to say minus 15 square. So what is minus 15 square? That's 225. Minus 10 square, that is 100. Minus 5 square, 25. 0 square, 0. 5 square, 25. 10 square, that is what? 100. Is that clear now? So after this, let me just clean part of this place now. Can you still pick that? So here now, we have to end the final thing, which is the formula here. So that is, we are going to multiply the frequency by this now. So that is f multiplied by x minus x bar, or what? All square. So this is a point where you are going to find 4 multiplied by 225. 10 multiplied by 6. 25 multiplied by 8. 0 multiplied by 10. 25 multiplied by 12. That is why I showed you an example there. So this is going to give you 900, and this will give us 600. This will give us 200. This will give us 0. This will give us 300. 10 multiplied by 100 will give us what? 1000. So when you total everything here, you will get 3000. So meaning to find our variance now, R squared is equal to summation f into x minus x bar all square, everything divided by what? Divided by summation what? Summation f. So which we have get the whole of this, which is what? 3000 divided by, what is our summation f? Great, that is what? 50. So when you use 50 to divide this, what is that going to give us? That will give us what? 60. So our variance is equal to what? 60. So what is our standard deviation? Our standard deviation is just square root of what? Of variance. And we have got our variance. So that means this is just square root of what? 60. And what is square root of 60? That is 7.75. Ladies and gentlemen, we have got this. So what I'm going to give is that I'll just give you one assignment on the group data as well. But if you have questions, I'm going to get into this now and ask for your question. Question. If you have any question, you can put it. Please, sir, kindly re-explain in the last column. So the last column is just multiplying this f. This x minus x bar all square, you are multiplying this with the frequency. That's why I've shown the example here. 4 multiplied by 225. This is 6 multiplied by 100. This is 8 multiplied by 25, which is equal to this, which is equal to this, which is equal to this. This is 10 multiplied by 0, which is equal to this. This is 12 multiplied by 25, which is equal to this. And this is 10 multiplied by 100, which is equal to what? 1000. Is that clear? So if you have any question now, I want you to ask. So I'm just going to quickly give you this as an assignment. You can drop your response on the WhatsApp group, or you drop your response on the comment section. So I'm going to clean all this quickly without wasting much of my time and give you the assignment. Then I will go back and sit down, and then if you have any question, just let me know. And like I said, so this is going to be a score interval. Score interval. A score interval. This is frequency. I have 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 29. This is very simple. Very simple. 6, 9, 12, 14, 9. And the total is what? 50. So find the variance. That's number one. Then number two, find the standard deviation. So ladies and gentlemen, if you come across this video, you can like the video. Also like to subscribe to this channel as you are joining now. And I'm going to meet you on the other side of the class. So let's meet on the other side of the class. Then we'll ask 1 or 2 questions if there's anything. So you are going to do this and then put your answer for variance and standard deviation in the comment section. I'll be waiting and I'll give you till, let me say, giving you till tomorrow to get the answer in. So I'm waiting for you. So I'm going to wait for you here now. So I'm going to wait for you here now. So I'm going to wait for you. So if you have any question, you can drop your question in the comment section. Please can I explain from the 4th column? You go back to the video after we end the class, then I can explain that to you in the comment section. Of course, so as you can see, this is the assignment. So I want you to work on this as an assignment. Work on this as an assignment. The heading of this is not clear. Which heading? Go back to the video, you see it on the video. Kindly state the importance of the measure of dispersion. You can go back, you can easily go back to the video and listen. You can easily go back to the video and listen. So I promise we are just here to spend an hour with ourselves. Just go back and listen to the video and make sure you do the 2 assignments. One assignment on group data and the other assignment on group data. So just do the assignment and make sure you submit the assignment at appropriate place. So ladies and gentlemen, thank you very much. And I'm sure you really enjoy yourself with this class. So see you at the next physical class. So we are meeting next class again, and we are going to move on to another topic. Thank you, and God bless you all.